Your average question is coming up here.
I feel
I've got it built in.
I'm excited.
Oh, I can't wait. I love this.
20.
I got 20 of them, so I'm assuming what you guys did was you say, oh, here's 26, and then I added up that, plus that, plus that, plus that, plus that.
Yeah.
So 20. Good. 20, and since there are 100 in the sample, that's 20% of the sample. Keep that in the back of your mind.
So the rest is the...
Keep that in the back of your mind. Do the same thing for 29 pounds. Strictly less than 29 pounds. Strictly less.
36 and
Let's see, I got
49?
47 or 49.
29,
49? Okay. I'm getting 49. Remember, don't count the 29 pounders, just count the 28 and belows. Strictly less than. Strictly. This is why I gave you that quiz problem on your primers. What percent of this number is less than whatever? Just to get you used to that counting idea. We're getting 49. That's 49%, which is essentially half. So, what we just discovered was, we know what the median of this data is. Because we know the weight that separates the bottom half from the top half is right about at 29 pounds. Now, if I asked you guys where you'd have to balance this tray of cookies, tell me where you'd balance it. Here we go. I'm going to put the hat over here.
Right there.
20.
Right there.
Somewhere here, maybe? Keep going.
There.
Now, notice, this average is left of where that median is. Yeah? That's why we're developing this, Michelle. Because what happens when your data starts getting skewed? When the average isn't tied necessarily to where the lion's share of the data is. Sure, this is a minor skew, it's not crazy. But what if it's majorly skewed? We need a tool to deal with major skew, and this is going to help us deal with any level of skew. Fair? Makes sense.
Yeah.
I'm just trying to deal with that. Your face was, you had that look of consternation, like, holy crap, I finally get this, and you're going to change it on me. It's not change.
It doesn't answer the question. Like, it doesn't answer why.
Absolutely.
Why.
Good. Now you're starting to see why. You're starting to see why. And Scott, you're starting to see why the 50th percentile isn't always the average. Sometimes it is. If the data were more, for example, if it were more symmetric, bell-shaped, for example, the median and the mean would be exactly the same, arguably. But as the skew starts, and the bell starts getting shoved to one side, your average hand has to go to this side to balance these cookies over here, these extremely odd cookies that are over here. Does that make sense?
Yeah.
Fair. I'm not saying the old tools aren't useful anymore, but it's the same reason on your workbench at home you have to have a flathead screwdriver for all those old things you have to fix. You have a Phillips head screwdriver, you have to have a hex head screwdriver, and you probably have to have a number 1, number 2, and number 3 Phillips, because the damn things are different sizes. And then you have to have a T50 bit, a T45 bit, a T40 bit, a T50, you see what I'm saying? They're all tools for different jobs, yeah? And if you try to use one for the wrong one, you strip screws, i.e. do bad statistics. Good? All right, ready? One more time. How many are less than 31 pounds? A lot.
70.
That's a good answer.
70, I think. Oh, wait, it would be... It would be 80, I think.
I'm going to cheat.
Well, 31...
I'm going to do 31 and over and subtract it from 100. How's that?
That's what I did.
Good! I'm thinking the same thing, Riley, because I agree it's a lot. So there's 11 31 pounders, 8 32, so that's 19, and 1 33, that's 20. That means there must be 80 that are less than 31 pounds. So what percent of the sample is less than 31 pounds? 80% of the sample. You now know what Max's weight was. Now, this would have to also assume that we've got a definition that we can agree on. Here's the definition that pediatricians use. A percentile, or also sometimes called percentile rank, is simply the percentage of a data set that you exceed. So when they say Max is in the 80th percentile for weight, that means he's heavier than 80% of kids his age. It's what you said, Michelle, earlier. You had the definition that pediatricians use. When you said it means that the 80% are below him, that means his weight is more than 80% of kids his age, white American 2-year-old males. When he was in the 90th percentile for length, he's longer than 90% of 2-year-old white American males. When he's in the 85th percentile for head girth, exactly, it's fun to even say, he's head girthier than 85% of white American 2-year-old males. Yeah. He's head girthier. I'm not correlating that with intelligence. He's pretty damn smart. Faith, go.
Okay, so if he's on the upper end of the 80th percentile, so then like the average, like straight across the board, would they be like the baseline? They're zero.
Well,
Zero.
that's a bit of a loaded question.
They're smaller, like
Right,
really
that's,
tiny ones
so
with strings there.
you gotta realize where I got this from. So where I got this number from, when they say the 80th percentile, what they have is a growth chart and they put a pencil dot
Yeah.
where they weigh him at. There's a lot of precision issues with that, obviously. This is not a scientific number with any kind of, it's 80th, it's probably to the nearest 5%. He could have been 75th or 85th that day, and 80th was what they settled on. And I mean, you're saying, like, I know this totally. And that's okay, because the idea is, and I want to come back to this, how this was interpreted. I'm not so much worried about where it is. Let's just assume it's 80, rather than 82 or the high end of 80. Let's not even worry about that. Let's assume that the population is so huge, they were able to drop his weight in precisely at 80%. Just don't microanalyze it too much. Now, I like that microanalyze, especially, actually I want to macroanalyze it momentarily. I put a however here. I want to come back to that, Faith, thank you. There are alternate definitions.